Hi, can everybody hear me okay? Okay, good. Welcome to my talk, Enterprise Development on a Shoestring Budget. My name's Chris Tankersley. Who am I? My slides aren't up. Good people. There we go. That's me. I've been doing PHP for 9-10 years now. If you want to check out my GitHub page, you can. There's a lot of software up there that nobody uses, but I keep it up there. Looks nice. As it pertains to this talk, I've worked on and in enterprise solutions before. I actually spent about 4.5 years in insurance and having to deal with enterprise vendors and having to build our own kind of enterprise software. So before we get too far, what exactly is enterprise? Well, if you're a manager, you think you're getting robust and powerful software that will help you think outside the box to paradigms you could only imagine. And in theory, if you're spending that much money on stuff, it should be very robust, very powerful, take care of all of the problems that you need. And especially if you're buying consultingware, which a lot of enterprise vendors will sell you, that what you're buying is going to actually fit your needs completely, because otherwise you wouldn't need to buy it. And since you're spending so much money on enterprise software, the people that are developing it are using standard practices and best practices so that you get good quality software. If you're spending $50,000 on a piece of financial software, you are assuming that it's not someone's CEO's nephew that just got out of high school. So the people that are doing the work should know what they're doing. But as developers, we know what enterprise software usually means, and it's usually overly complicated software. I actually had financial software that we bought from a Fortune 500 company that to do wildcard queries, you had to put the percent sign in there. Anybody who's familiar with percent sign is, that's what you do in SQL. We actually put raw SQL in the search query. Most of the software is unrealistic in the scope that you purchase them in. A big problem with it is consultingware, where you buy a base package and then they will customize it for you. Most of them allow you to keep just piling features on top, and you get scope creep. And what you purchase them for, they can't actually do. And of course, they cost lots and lots and lots and lots of money. It was not unrealistic for, especially my employer, to drop $200,000 on software because they thought they were getting robust, powerful software. Now, as a developer, when I made my own enterprise software, I focused on the top 3 things because I didn't want to be the bad developer that, was just there to make money. I like to make money, but I also want to provide good software to my clients. So how do we become enterprise without becoming the bad kind of enterprise? The first thing I think you should look at is the Joule test. How many people here are familiar with the Joule test? A couple? Okay. For the people that don't know, the Joule test was originally designed as a way to evaluate your company or a potential employer through a series of, I think, 12 questions. And the higher the score, the better of a job that would be to work at. There's some parts that we can use to look at our software development to see how well we're doing. We don't need all 12, we just need a couple of them. Good project management is a huge stepping stone to actually building good software. If you don't have good project management, it's going to be really hard to keep track of what you're doing. And managed environments. You want to be able to have environments that you know will always work and places that you can trust where code is always going to work. And especially nowadays, we want to automate things as much as possible. Most of the problems I've seen with enterprise software are steps that could have been automated that are completely manual. A different financial software I had to deal with, when you got a new update, you had to download 5 Windows packages, run them in a specific order, then go get a SQL file, which depended on the version of SQL Server you were running, and manually run that SQL file. Deployment of the software took about a day. And accounting doesn't like it when your accounting software is down for a day. And a lot of that stuff could have been completely automated. And of course, standards. In PHP, we've got Fig. If you don't like them, pick your own standard, but standards are good because it lets people come onto the team quickly, and it lets people know what the expectations are. So let's talk about the Joel test a little bit. Like I said, we don't need all of the questions. There's just a couple pieces we need to look at. The first question is, do you have specs? If you start a project and you get a one-page spec, you're probably not going to actually know what you need to build. Usually, the reason you get scope creep in a lot of projects is because things were not properly spec'd out. Do you use source control? Does anybody here not use source control? Good. We will go through those slides very, very quickly then. How many people can make a build in one step? Nobody? One? Okay. The quicker you can build your site, the better you'll be able to deploy it. And the original question is, do you make daily builds? But I think a more appropriate question for us is, can you make a build on demand? So if you can make a build in one step, can you do that anytime you want? And do you have an up-to-date schedule? Are you ahead of schedule? Are you behind schedule? Do you have a bug database? Probably most of us do, but there's a lot of companies that don't keep track of those kind of things. So kind of all of that rests on project management. Pick one. It doesn't really matter what kind. I've got Scrum and Kanban on here, which are agile. But you need to pick some sort of project management style, and you need to actually learn it. The most frustrating thing is working on a project with a project manager or trying to manage it yourself without understanding how everything works. Because it's really nice to say we're agile, but if you don't know how to actually manage the workflow, being agile doesn't get you anything. So pick a project management type, go online, buy books, learn how to actually do it. Once you've got a project management style, see how they want you to design your specs. A lot of them have you do user stories, which can be little one-liner things, or it could be a full, little narrative that tells you how your site's supposed to work. Some of them, if you use things like waterfall or big design up front, you have to build formal documents. But get those specifications in place so you know what kind of work you need to do. And stick with it. If you, for example, pick Scrum and you start a project and it turns out that's not really useful for your group because maybe you're too small, I would say stick with it through that project and change it afterwards. It's really annoying to have to turn around and change project management styles in the middle of a project. That can screw up schedules, that can screw up budgets, that can screw up all kinds of things. So stick with it, and like I said, you're going to want to invest time learning in it anyway. There's some tools you can use to keep track and help you with this because we're not all project management gods. One of the most popular ones is Basecamp HQ. This is really popular among, especially managers. It's basically a glorified to-do list. Basecamp will break down if you try to use it for bug tracking or historical tracking or things like that. But if you can get away with using to-do lists, Basecamp's a really good option to use. There's one called Planbox, which actually we use at work at the Brick Factory for our Symphony development. And it's an actual agile project management. You can go in, you can put your user stories in, you can put in time estimations or action points, figure out how much work your team's getting done. And if you don't want to spend money or you can't get your company on board to actually getting project management tools, use a spreadsheet. Set up a sheet with all the stuff you need to do, set up another one who's working on what, and then another one on who's got stuff finished. Or worst case, get a whiteboard and a corkboard. Stick index cards on there and figure out what's going on. Project management doesn't have to be pretty, but the act of doing it will make your life much easier because you can come to the client and say, I'm sorry, we're 3 months behind. Hopefully you're not 3 months behind, but at least you know you are. Once you've got good specs, you can turn around and you can actually build a schedule. Runaway projects from both a client and a developer side are a nightmare. You don't want to say you're going to build a piece of software in 6 months and it turn out that it actually should have been realistically 9 months. And take your specs and put a price on them. If you're doing work internally for a company, you might have to bill other departments. Or you, at the very least, you need to budget your time. If you're an independent consultant, you want to know that you're charging your client the correct price. The last thing you want to do is undercharge somebody, and you don't know if you're undercharging until you have a good scope of the project, which requires good specifications. And of course, there's the old adage of you can build software 3 ways, fast, right, and cheap, but you can only pick 2. Having specifications will allow you to build a schedule and charges and allow you to stick to 2 of these 3 rules. So if you know it's going to take you 6 months, but the client wants it done faster, you know that it's going to cost more. And the other nice thing is if you have actual specs and, for example, there's a contract that they signed up on and they want to keep adding stuff, you can always point out that, well, it's going to cost you more, so there goes cheap. Managed environments is a lot easier to deal with nowadays. But for managed environments, really what we're looking at is a work area with a specific purpose. So you should have at least 3: development, quality, and production. And they all have their own individual reasons for being there, and all have different jobs that should be done inside those environments. If you can get away with it, I'd also throw integration in there between quality and production so that you can actually test deployments. But get at least those 3 set up. And a big rule is code moves up, not down. So to be honest, who here still edits in production? Nobody? Good. So in your development area, you should never know what's actually going on in here. This is the developer's playground. It could be broken 1 minute and working perfectly well the next. And you never want to consider the code here stable. So if you have a meeting with a client, don't show them the dev server. That's what quality's for. Because the last thing you want is to go into a meeting and it turns out that Bob is checking paddings and margins and everything's pink and purple. And it can be any kind of machine. You can set it up locally on your machine if you're running Linux or OS X or Windows using like Zen Server or native packages. You can do it in a VM. If your IT department makes you can set up spaces for it. It doesn't really matter what it is. I recommend that you at least use the same versions of like PHP and MySQL as whatever production is, at least major versions. So don't use MySQL 5.6, but you're running 4 in production. I hope you're not running 4 in production, but. That brings us on to the quality environment. So the idea is here, everything should work. Now we can always introduce bugs through coding, but anytime you go to the quality environment, you should get a web page. It should work. You should be able to log in. This is where your QA testers are going to live. So if you have your project manager actually testing the software, have them look here, not on development. Have your client meeting use quality, not development. And this should be as close to production as possible. The OS should fairly well match. The PHP version should match. The MySQL version should match. Because sometimes you might work in PHP 5.5, but you're deploying on 5.3, and stuff will break. I know one of the biggest issues I had was doing WordPress development. We would do all of our development internally at PHP 5.3 because we would deploy on Rackspace, and that's what they supported. Well, we would get clients that support 5.2 only. Well, there's some things you can do in 5.3 that you can't do in 5.2, and you want to find those out long before you have to push them into production. And you should have logging completely on and debugging on. I actually say turn display errors on. That way you can make sure everything that should go into the error log is caught before you actually get into production. Because things like undefined indexes, when those have to write out to the error log, that's extra time and processing that your site has to do. It's kind of a micro optimization, and those things are bad, but you want to work with clean code and have that stuff work properly. So in quality, have all that stuff turned on, especially with logging, so you can go and see when things break. And then with debugging, you can get rid of those things very quickly. The thing I hate the most is doing Drupal development, and we go put a theme in place, and all of a sudden you get boatloads of errors because the original developer, whoever we got the base theme from, didn't do any kind of index checking. We had gotten one, which we don't use anymore, that didn't put quotes around his array key names. You can imagine the kind of logs that generated, but without the errors on, we would have never necessarily seen that. So the next level up from quality is integration. This should be basically production. Because in here, you're going to check for deployment bugs. So your code can be worked on in development, checked in quality, but then when you move it live, does it actually move live properly? A lot of times we'll do database schema changes, or we'll add new folders and we'll need to set up permissions. When you push your code live, does all that stuff work? I have had it happen where you have to do data mangling because you're changing tables. For example, you might have an old table that you're now normalizing. Does your production data actually get converted correctly? So to test that, you need to use production data. And like I said, really all the code that gets here should be vetted and worked. You just want to make sure the deployment works. And since this is production light, it should be the exact same thing as production. Same operating system, same configuration, version numbers match exactly. And that leaves us with production, which you don't ever touch. If you can get away with it, don't have access to production, or only have access to the logs. By the time you get to production, especially if you have an integration environment, everything should work. You should have done your due diligence to get to this point. Now, you can run into problems in production because that's where bugs will pop up. So you need to be able to get your logs and do that kind of stuff. But you don't ever want to have to actually work in production. So managing environments is a lot easier than it was, say, even 5 years ago. I think the easiest way to do it is through virtualization. You can use things like ESX and VMware or Parallels or whatever. But two of the big things now are Vagrant. And as PHP developers, we now have access to Puppet or whatever Juan calls it, because he won't tell me what the name is, so I'm just going to call it Puppet. But you can go generate configuration scripts and VMs for all of your developers, so everybody's working across the board. Now, part of what Vagrant uses is configuration management, which is a lot of what Puppet sets up. But if you don't want to have to use Vagrant, for example, maybe your IT department won't allow you to run virtualization, you can use configuration management like Puppet or Chef to get a list of configs for all of your boxes. So if you have developer machines, you can set them in Puppet so they always have the same version of PHP in. You know integration's the same because it's using the same Puppet configs as production. And if you can have configuration the same across from development all the way to production, your life just gets much easier because everything should work and you should be able to reproduce bugs anywhere along the line. And as developers, we love software. We love software so much we build it ourselves. My biggest advice is learn to love your IDE or text editor. I know we all started out probably using Notepad, Notepad++, some very basic things. But there's some developers that still use those very, very basic tools. Or we buy things like Zen Studio or PHP Storm, and we never learn how to use them. So pick something, and it could be an IDE or a text editor, it doesn't matter, because they both serve different purposes. For text editing, I usually use Vim or Sublime Text. You can use Emacs. For IDEs, I usually use Zen Studio or PHP Storm. If you're trying to save money, the thing that I would recommend the most is spend money on an IDE, a good one. And vet and evaluate each and every one of them. For the longest time, I used NetBeans, because at the time, it was the best one that was there. Now, I switch kind of between Zen Studio and PHP Storm, because they give me more power. One thing I really like in PHP Storm is being able to get to my database directly from the IDE. I don't have to drop to the MySQL command line. One thing I like about Sublime Text is the plugins. Same thing with Vim. I can get a lot of stuff done with powerful Vim plugins that sometimes are hard to do in IDEs. And source control. Everybody here said they use it. So those are my recommendations. But if you're already using source control, good job. Now, QA. Does anybody here have an actual QA department? A couple people? Okay. Not all of us can have a QA department. And if you do have a QA department, some of these things will still be very, very useful. But my biggest recommendation is automate your QA. The reason you want to automate it is you want to make it easy for your developers to do their own QA. And you want to make if you have actual QA testers, you want to make their lives easier by allowing them to reproduce a lot of their tests. For developers, we can use things like PHP Unit and Behat. Your QA people probably won't use this, but we can use unit testing or behavior-driven testing to make sure our code always works. Because if you are adding a new field to your user, and because let's say you want to only partially suspend them, maybe it's suspension with an error message as opposed to not allowing them to log in, you want to make sure that that's not going to break the rest of your authentication code or break something else, for example, user sessions. Test-driven development gets brought up a lot at PHP conferences because it does work. You can save yourself a lot of time and heartache by looking into either test-driven development or behavior-driven development and getting those into your workflow. And for stuff, if you do have a QA department, and for the stuff that you can't do in unit tests, you can look into functional testing with things like Selenium or Phantom.js and Casper.js, which will run through your site as if you're a user. One of the most expensive pieces of software I can think of off the top of my head for QA is a piece of software called HP Functional Testing. It's one of those pieces of software that it's so expensive they don't tell you how much it costs, because if you have to ask, you don't have enough money to buy it. All it does is allow you to record clicks and text entry. So you pull it up, you tell it, go to this web page, click in this text box, fill in this username, fill in this password, click go. When it goes to the next page, I should see this string. We can do that using Selenium, which is free, which Michelangelo talked about earlier today. And there's other ones like Phantom.js and Casper.js, which will run headless WebKit. So you can test against things like Safari and just raw WebKit. So every time you make changes, for example, we add that field, we can run through Selenium. We know it passed our unit test, but does our JavaScript and stuff still work? We can use tools like this to constantly test and make sure it works. Your QA people can use things like Selenium and Phantom to reduce the number of clicks. So they can just write their tests, save them off somewhere, and run them over and over and over and over. And then there's metrics that we can run, like PHP lock, which will count the number of lines in your code and give you stats on how many are comments, the actual code, white space, that kind of stuff. PHP mess detector, PHP code sniffer, because if we're using standards, we want to make sure they're being enforced. Because if, let's say, we are using PSR2 and 3, is that piece of code Bob checked in actual PSR2 and 3? You can run code sniffer to find out. And probably one of my favorites, and one that's actually useful, especially if you have to work with a lot of junior developers, is copy and paste detector. I think it's Anthony Ferreira has a rule of twice you can copy and paste a piece of code. Third time you've got to refactor it. This will let you see that, and you can then turn around and use source control to find out who actually did it. And a lot of this stuff leads to continuous integration. And really all continuous integration is the act of automating all of your build tasks. So that's where we can get to the push button deployment. Now, we don't compile software in PHP, so we do a bunch of other things to build software. So we will check out the source control, or the code from source control. We'll run all the unit tests. We'll run any code helpers like PHP lock or PHP code sniffer. We'll build the documentation, and then we'll package it up. You could use a ZPK file for Zen server. It could be a tar file. It could be a folder somewhere. But the idea is you can get this to run automatically or every time you want to do something. So if you run this every time your build gets checked in, let's say every time you set up your deploy branch, you can have it run through and just make sure everything works. If something does break, you can then probably go back and figure out who it is and have them fix it. And if you're using things like PHP Documenter, you can automatically build your code using things like continuous integration. Probably the two most popular ones right now, one is Jenkins, which is kind of a general purpose build tool. And if you go to jenkins-php.org, there's templates all pre-set up that will show you, or that will get you set up for PHP development. And then there's Fing and Zinc, which are PHP implementations of a continuous integration software, and then Fing is actually a build tool. And you can use Fing inside Jenkins. They're not mutually exclusive. But the idea is you've got a lot of that stuff automated so that you don't have to worry about it. You don't want to have to spend your time checking people's code in, running their unit tests, building documentation. There are systems that will do it for you, and your time can better be spent doing other things and having to do a lot of this kind of dirty but necessary work that a lot of projects have to do. So now I've talked a lot about ideals, but how do we as developers who have legacy applications and things like that actually get this to work in the real world? And really all I can say is you need to start getting these pieces into place. Each place is different, but the flow that I usually recommend is, first and foremost, get proper specifications. If you see that most of your projects are failing because of scope creep or runaway schedules or bad budgets, check and see if you're actually getting real specifications. Again, one-page specification document's not going to do it. Specs can sometimes take time, and I know the argument I always get is the client doesn't know what he wants. But as developers, especially if we have to deal with the clients or our project managers' jobs, is to play 20 questions and get those specifications. After that, get source control. But you all have source control, so I'm not going to harp on that. Get task and bug tracking. Task tracking kind of goes with proper specifications and project management. But especially bug tracking, you need to start keeping track of these things. Unit testing and functional testing will only do so much. They are not silver bullets. Your tests can be bad, and you don't test for everything up front. When bugs happen, you want to see that they're properly documented, that they're properly resolved. And get the environments. Now, people like me, independent consultants, I can say I'm going to use Vagrant, and that's how we're going to work. Work with your IT department or whatever to find out what you can do to start managing your environments. I myself, like I said, for the work I do, I use Vagrant because I work across many machines. It's very easy for me to deploy. Because I use Puppet in production, I can use those configs to build my Vagrant boxes. At my previous job, we had all of our dev environment set up on a VM, or different sections inside of a VM. So we had like 7 vHosts total set up. But once the environments are set up, we can make sure that people are stop stepping on each other's toes. And get the tools. I put this last because I think without all the other things in place, no amount of QA or automating the process is going to solve larger issues like bad specifications or source control. And depending on where you're at, you may fall somewhere already in the strata of this. But all I can say is you need to start looking at these, figure out what's wrong at your organization or in your workflow, and start getting a handle on a lot of this stuff. And of course, automate as much as possible. How many people here are 1 or 2 person shops? Couple? Okay. That saves you time by not having to worry about constantly F5ing or going through and checking a huge list of bugs that you know existed and you want to make sure that don't crop back up. For people that are in larger places, automating it will allow you to effectively blame people when things break. So you know that that person can be notified and can get that fixed for whatever, however they broke it. And really every step but specifications and scheduling can probably be automated. You can get tools now that will automatically set up and provision your environments. So every time you get a new client, automate the process of setting them up. Set up a production server, an integration server, a quality and a development server with the push of a button. There's plenty of vendors here that you can talk to see about doing that. But again, that saves you time. Even if you have to manually set up the boxes because you're running Zen at work, put Puppet on all the boxes. That will cut your deployment time from 3 hours to 30 minutes. The biggest savings I found for me, especially with new clients, is running Puppet. And you can use Chef as well because they solve the same problem. But I could get back to doing my work much quickly by saying, install Debian, install Puppet, and 15 minutes later, I'm done. The box is ready to go. And you don't have to automate everything because some automation is better than nothing. So if you can, start automating your builds. At the very least, run unit tests every time a build is checked in. Because you want to start small, because you can't push big changes, especially like automation, in one huge push. You need to get people acclimated to what's going on, and especially if you have to deal with an external department like the networking department or the operations department. You need to have them on board. So if you can't get everything through, automate what you can. And like I said, for development, get a good IDE or a good text editor. Doesn't matter. Something that works well for you, that gives you a lot of power. Use those QA tools because you want to be able to figure out if everything works before it gets to the QA testers. Because their job should be finding things that you missed, not finding the bugs because it's not your responsibility. Use those tools, use test-driven development or behavior-driven development to actually get up and running quicker and know that things are broken and not have to give broken things to people. And keep track of bugs. And be very, very strict about the bug process. The people that, a lot of the organizations that I've been in, we put bug tracking in place and then people don't follow it because it's easier to email someone. But the problem with that is if they don't know they're on vacation, no one gets that email. No one knows whether or not it's been resolved. No one knows how long that bug's been there. Is it a bug that keeps popping up? If you don't make sure that people follow the process, then you can't properly track them. Now, I'm a little bit ahead of schedule because I guess I talked a little bit quick. Does anybody have any questions on any of the stuff that I talked about? No? Okay. Well, that means we get to go to dinner a little bit earlier. So I will have these slides up on GitHub. Again, my name's Chris. There's my email address. You can find me on Twitter as DragonManTank. And I will be around the conference for today and tomorrow if anybody has any questions. Thank you.